All right, ladies and gentlemen, we're going to kick off our first session today from Aleo blockchain. Please put your hands together for Mr. Daniel Hwang from Korea, ladies and gentlemen. He's the validator ecosystem lead for Aleo. Yeah, it's on. Yeah, there you go. Take it away, Daniel.
Cool. Okay. Yeah. Hi, everyone. I'm Daniel. I help out with the validator and the ZK mining or /ZK proving ecosystem on Aleo. I'll just do a really quick introduction of myself. I used to lead the protocols team at Stakefish and led the special projects team at F2 Pool. So F2 Pool was the largest Bitcoin mining pool in the world, and Stakefish was the largest Ethereum validator, non-custodial validator in the world. And so I guess that's a good connection to Ethereum. And maybe my personal connection with Aleo is when I was studying cryptography in grad school, Matt Green was my advisor. Do you guys know who Matt Green is? No one? So Matt Green was one of the co-authors to the Zcash paper, along with Ian Myers, who was also a professor at one of my universities. And then they came out with a paper in 2018 called Zero Knowledge Execution, which was basically allowing smart contract privacy. And so a bunch of the co-authors to that paper, specifically Howard Wu, left their PhD programs and then started Aleo. Maybe the direct connection to the Ethereum ecosystem and broader ecosystems, I would say, are twofold. One is obviously the ZK aspect is the scaling that's been offered. But also, I think the second most exciting thing about these ZK ecosystems is the establishment of a brand new infrastructure class. So if you're familiar with Bitcoin and the POW chains, you have POW miners. With POS, we have what are called validators. And just coincidentally, I had worked quite extensively in both ecosystems. And now with the rise of ZK, we have a third infrastructure provider class called ZK miners. And so it's quite exciting. It's quite exciting to be a part of this sort of brand new infrastructure sort of development. I think a lot of what these ZK chains or ZKL2s or ZK ecosystems would say, beyond some of the scalability affordances that ZK gives you, is that you have this sort of blue ocean opportunity. And then obviously POW style ZK mining is the beginners benefit from it. So this is a pretty interesting slide sort of for the evolution of what we've been seeing in the crypto ecosystem. So you could see, I kind of broke it down into infrastructure classes that we've been seeing over the past 10 plus years. I myself I used to be a big Dogecoin miner and Bitcoin miner a long time ago, 2013. But so what we see is sort of this, not just the infrastructure class evolution, but we also see sort of the possibility for more, I guess, technology improvements. So what we have is these old Chom-based cryptocurrencies like DigiCash, Hashcash, and then Bitcoin was able to solve a pretty critical element in incentivizing good behavior with proof of work. And eventually, a lot of development had come there, and specifically with ZK, we saw Zcash, essentially a fork of Bitcoin that allowed this privacy to be provided. And then, why Ethereum existed was this programmability aspect. And so with the rise of Ethereum and its transition eventually to POS, we have now validators, with this ecosystem. I think a very sort of rudimentary way of imagining some of these ZKL1s or Aleo is that you have now the ability to have this sort of privacy and scalability layer with ZK to also have, right, the programmability that you have with Ethereum and these types of smart contracts. And so I think maybe one way to think about it is, right, this is sort of like the next domain of evolution for what is possible on this sort of technical infrastructure stack. Mind you, right, zero-knowledge proofs has been around since the 1980s, right? And only recently have we sort of seen enough technological advances to make use of that in both mechanism design and hardware. And so I think one of the sort of side goals or side effects of this incentivization mechanism that cryptocurrencies and their associated blockchains provide so well is that you have this sort of hardware infrastructure that's being developed. Really quick anecdote is, like, I used to do bioinformatics research for about 6 years when I was doing a lot of distributed systems work. And, right, we had used, right, ZK in the process of something called like fully homomorphic encryption, which is basically you can run computations on encrypted data. The problem that we had was that, let's say we had 6 different labs and we all wanted to share, right, genomic data with each other and run computation on it, but, right, we didn't want to give up our data because it was expensive. So, like, very specifically, what I did research was on human gut microbiome, and you get that from poop. It's very expensive to get human poop. And so what happened with the problem with FHE is that you have to encrypt the data before you can run computation on it, but then you don't have the ability to verify whether or not that data that you put in and encrypted is good data, right? You can just put trash. And so we had used ZK to prove certain properties of the data that we had in order to put it in and have the peace of mind that we're not all getting screwed by each other. And so what we had to do is, right, at least in America, we had to write these like lengthy National Science Foundation grants to be able to get enough money to run ZK on the cloud. And so I think that is a small example of what's so exciting about now this sort of like perfect storm of what we had seen evolve in the past with these infrastructure classes, notably what we have now with ZK mining, that has the ability to give us sort of like this marketplace of service providers that can sort of help people like me if it was like 7 years ago. And so I think also, right, the interesting point of why cryptocurrencies exist is namely to have this sort of incentivization mechanism that now can be going directly to an infrastructure class that can be sort of like getting paid for their work. And the direct example there is, right, back in 2013 when I was mining Bitcoin, we were all doing it because, right, we wanted to burn down the banks, et cetera, right? But the reality is that, like, we all did it ideologically and we had no idea like what Bitcoin's price would be. Nowadays, what you would have with Bitcoin mining and specifically, right, when I was working with F2Pool, Bitcoin miners, right, and the mining farms don't necessarily have to have that ideological resolve to sort of be participating in the network. They get paid for it. And so there's the very key point in how good behavior as designed by these systems has to be incentivized. And that incentivization allows these large companies like Bitmain to exist, right? Bitmain manufactures like 90% of the entire world's POW ASICs for Bitcoin. And they're only able to grow so large and develop this very specialized hardware because they were getting paid for it, right? Bitcoin's rise in speculative value, value is what drove it. And so with sort of like this idea of technology advancement that we had gotten to with the appropriate people who have largely, right, like contributed most of the seminal work on zero-knowledge proof research, at least from the cryptography side, as we had seen with Matt Green, Ian Myers, Chiesa, and the rest, and Howard. And we also have this ability of understanding how infrastructure does evolve. And the next step is sort of like this programmability that we have with privacy with ZK. And so I think personally it's quite exciting to me, right? Over the past like 10 years, we've been seeing this evolve. And we're beginning to see sort of this this work in effect. And so I'll describe some of this. I already described a bit of this, but we have like this sort of like this maxed out sort of scale on privacy and programmability, right? Ethereum was created because Bitcoin was not programmable enough. Zcash was a fork of Bitcoin that allowed privacy. And then now you have both programmability and privacy. And I obviously described some of the brief mechanism of why we need to have this sort of POW style proving mechanic for the ZK proofs, and then some of the programmability that Aleo has provided. The explanation of some of these, right? So this unlimited application runtime is largely due to some of maybe like this sort of scalability features that many of you might be familiar with coming from like the L2 side or some of like the ZK side, is that you have this set of infrastructure providers, aka these ZK miners, or you could call them ZK provers, that can sort of like run this computation in a verifiable way. Obviously, right, if you want to get very technical or semantic about it, you're just like kind of moving the trust layer to another degree. And maybe to compare it to like rollups, specifically the optimistic kind, right? You have the trust in math versus sort of like this game theoretic trust in that someone will be able to capture some of that. I think one of the more popular failures or more popular attempts at sort of like the game theoretic sort of bounty hunter system that we've been seeing versus sort of like this mathematical guarantee through ZK is, if anyone's familiar with Polkadot, right? Polkadot used to have something called Fisherman, but Polkadot deprecated that away. And so you can basically run programs off chain that can be verified mathematically through ZK. Obviously, the caveat to that is you have to trust that the math is correct, right? But I really do think maybe one of the most unfortunate mantras that we've been seeing so often, at least in transparent blockchains, is this concept called like don't trust, verify, where the burden is on the user to be able to sort of audit their own smart contracts if they're going to be interacting with it. I mean, I consider myself a pretty technical person, but I don't think I've ever like gone through and audited contracts before I use them. And I highly doubt that any of you have either in a serious way. And so I think that type of usability is right, like a way that we can kind of move forward in sort of move forward from false paradigms that we had crafted. So one specific example that you can maybe take away from this sort of unlimited runtime is, right, if you want to run like a machine learning classifier on data, perhaps on let's say the Aleo blockchain or any other blockchain, for example, and making use of this infrastructure class, these ZK miners or ZK provers, is that you can kind of have like these classifiers running these as long as you want, and all you need is a simple proof that can be verified quite easily by the appropriate stakeholders and operators on Aleo. I think I'll get to this slide in a bit, but yeah. So now I'm going to come back to the beginning of how a lot of this is crafted. I think a really very reductionist way of thinking about Aleo is it's like Ethereum plus Zcash, right? You have programmability with privacy, right? As we'd seen in this slide, right? Like Zcash has privacy, but it doesn't necessarily have the full expressivity of programmability, and Ethereum doesn't have privacy, right? And I think that's also probably one of the most problematic UX issues that we've had, aka, right? I'm pretty sure most people in the world don't use Ethereum or Bitcoin as it was intended, at least to guard privacy, where literally you're supposed to like create new addresses or accounts every time you send transactions. But everyone just has probably one wallet that they use to transact with everything. And so, right, I will know your entire net worth if you just have one account. So privacy is quite important. And so what we have is, and maybe for some of you who have been following Aleo for the past 3 years, Aleo used to be based on something called POSW, Proof of Succinct Work. It is now, as of this year, transitioned to a hybrid POW style slash POS style ecosystem. And so the POW style part of Aleo is we have ZK miners, right? They run the proofs and they get rewarded for it through a Coinbase reward. And the POW style is basically the consensus and the block building that are done by validators. And if you're familiar with Aptos and Sui, it's the same sort of like consensus mechanism, bull shark, and the and it's narwhal for the transactions. Basically, it come from the DM and Libra team that Dalia Malki had set up, which was largely inspired from Rapid. Which, fun fact, I had used to do research with Dalia on Rapid. Quite old one, but and then yeah, Leo is the programming language for Aleo. One thing I would like to say about these, I guess, what you would call domain-specific languages, right, with Leo is that, right, we've been seeing a lot of these interesting approaches to, right, these new sort of like, these new blockchains or these new languages, and the biggest complaint, I think, is that it's very difficult for people to migrate to a new language to learn it, right? And so like, okay, how are you gonna get mass adoption and developer mind share? I think I would say two things maybe that you could take away with it, or maybe two and a half. Well, I guess like the half is that, right, programmers should have the ability to sort of like adopt new languages, and I think it's quite trivial for those of us who have the ability to build new stuff with it. And part of that is that you need to have like this ground up approach to be able to make use of a technology that is not necessarily easily sort of like retrofittable, or I don't know if that's a word, but like backward compatible, let's say. Yes, you can make compilers that can like translate things, but I think it's important to understand that, right, for something as specific as zero knowledge proofs, and you need to have like the appropriate tools to make full use of it. My analogies kind of suck, but like I think one way I try to think of it with the necessity of DSLs for ZK is that, right, you can have you want to sit down, let's say, right? And then you can sit down on a table or you can sit down on a chair, right? Both would sort of like fulfill the use case of being able to sit, but then a chair has been literally crafted to allow you to sit, I guess, most optimally or most comfortably, versus sitting on a table that eventually, I don't know, your back will hurt, et cetera. But and something that's quite interesting, especially with regards to, let's say, the developer mindshare that that people have concerns with this sort of like new languages, and specifically with Leo that has been built from the ground up by the team, and actually like Ian Myers had contributed significantly to it, is that I think, right, and we saw a lot of this in the early days of Ethereum, as, let's say, as developers or even as like ecosystem potential partners or projects, you need to be able to understand that, right, the demand should drive the desire to learn these new technologies. There's like a long time ago, there's like some study that had said like if you can pay, for example, a developer or allow a developer to run like $70,000 a year on technology, they'll crawl through glass, right? And so I think that's important to keep in mind, right? And especially not trying to like FOMO you guys, but like, right, being early to a technology and being a master at that craft and the ability to kind of like guide that to other people is quite fortunate, right? We saw Ethereum Solidity developers, even though those docs were quite trash in the early days, right, charging like $300 an hour plus, right, because there was so much demand for it. And like I think like the very small example that I'd given with the research that I'd been doing in the bioinformatics field provides a really intriguing and compelling use case for ZK being allowed to be used in both Web 2 and Web 3, right? It's not necessarily just like a speculative use case. And specifically on that, like a way you can kind of wrap your head around it is, for example, like I started like one of the first climate working groups in crypto, and right, everyone hated on Bitcoin because they thought it was burning down the planet, and artists hated it, right? The fact is that the aerospace industry emits 9 times more carbon emissions a year. But then, right, the difference between the value add that Bitcoin had and let's say what aerospace travel has is that people, right, value aerospace travel, and then they didn't necessarily like destroy the aerospace industry. Whereas like there are different examples of people saying Bitcoin is valuable or Bitcoin is not valuable. I would say at least, right, just in general, not just Aleo, but like with ZK, it's such an exciting way of thinking about how you can provide these infrastructure service providers that will exist that can service both Web 2 and Web 3, and this sort of like engine of incentivization that is powering these, which is the example of like how Bitmain was able to get created from Bitcoin. And so I think that's incredibly exciting. So, right, someone asks you like, why ZK, et cetera, right? You have this immediate applicability into both Web 2 and Web 3, not just speculative use case. And so, yeah, this is maybe to get more into technical weeds, right? Like validators will host applications on a registry. Provers will run the proofs that you want us to mine. Initially, what you can think of is, right, is in the start of the network, ZK provers will mine Coinbase rewards. And one specific caveat or difference between sort of like POW style, let's say like Bitcoin mining, is there's no winner take all, right? You already have this sort of like, you know, quote unquote, enshrined into the protocol like a pool, right? Sort of you can generate a proof in a matter of in a fixed time period, then all the provers or all the ZK miners will share pro rata for that. And so you can think validators are getting a share of the Coinbase reward that the ZK miners are mining, and then producing blocks from that. Eventually, what I think is going to be quite exciting for ZK miners and provers that are created from like these ZK-L1s or L2s, when we need it, is that these ZK miners would also have this sort of opportunity as a service provider to service other businesses like, right, research labs like my own. Yeah, and so, yeah, I kind of gave this example of like game theoretic security versus mathematical security. And then, yeah, this is what you probably are familiar with in ZK. You can have these proofs that are running through this language and this specific virtual machine that the provers and validators will run. Yep, we'll have a program registry for our validators. Maybe something that's interesting about Aleo is you have the ability to sort of have this sort of backward compliance with some privacy. So, for example, right, let's say the South Korean exchanges, they don't like privacy coins, right? Or even like all types of exchanges, where if you want to send a transaction out of a centralized exchange account into a private address, you can't do that, specifically if there are custody issues, et cetera. And so, right, that gives a lot of problems to these privacy ecosystems that do have certain things at default, right? If you're familiar with, like, if you remember, like Grin with Mimblewimble, and then like certain, let's say like Monero. Right, versus like what we'd see with like Zcash, which is like public by default and you have to pay a bit more to be private. Aleo has this concept of like sort of like a view keys, where if you control this private key, then you can technically sort of decrypt transactions that you had that don't necessarily have, you can prove certain things about it, right? You didn't touch a North Korean account, for example. And so, right, that's not obviously, right, that's from that spectrum, it's very clear that, yeah, transparency by default exposes much more than you probably would be comfortable with exposing. And you can only use it in a limited way versus privacy, and you have the ability to expose certain things, like, let's say, the U.S. government comes knock on your door and says, like, prove that you haven't been interacting with North Korea, and then you can do that. So it's very, very specific to how you want it. So I think that's something notable to have here. Yeah, you can have transaction execution here. So I think, and I went over some of the applications or possibilities here, right? I think one of the thing, and you guys can just like take a picture of this, but private stablecoins that can be compliant with specific opportunities for people to reveal things without revealing it to the entire world, right? Private DEXs or dark pools, I think, if you've been familiar with like Ren and what they were trying to do. And then you also have, like, I guess what's really popular these days, like ZKML. I think one thing I would like to say about ZKML, or like a takeaway, is that, right, with machine learning, you need to have more data to have effective models. I think the trend nowadays is that people are wanting to withhold their data, and so it's difficult. But then if you can like sort of like provide information and data, and then protect it or prove certain things about it in an encrypted way through ZK, then you'll have more data coming to that. Yeah, so yeah, I'll just leave this up. But one thing I would leave is that Aleo has a bunch of grant programs. Obviously, every project has grant programs. We have 3 different types. One is it goes from Ignition launch to Blueprint. And then the Ignition grants are around like 5K. The launch grants are up to 100K. And then the Blueprint grants are 200 plus. And I think what's the most interesting or exciting, at least from my end, is like the infrastructure. And then I think that's a really great opportunity for you to be build some infrastructure tools, right? You want to be EtherScan, be the first EtherScan. Though it does require you to understand the way that these systems work. And there's bug bounty programs. One other thing that I think would be interesting is sort of like the ability to have some more of this tooling be developed, sort of more distributed globally. And so it's why we're here in Southeast Asia. And obviously there's been a history and track record of a lot of fundamental infrastructure that's been developed both through like EtherScan and like stuff like CoinGecko. And yeah, take a picture of some of these. If you go to the GitHub in the bottom, that's some examples of programs that Howard, the CTO and the founder have created. You can go to an online IDE like the play.leolang. And then you can also, right, I haven't written here, but explore.aleo.org, you can kind of see like what's been going on in the test nets. And yeah, last 2 things is validator testnet is happening end of October to guiding up to mainnet, and mainnet is launched in December. So yeah.
All right.
Thank you.
Ladies and gentlemen, let's give him a warm round of applause. Thank you, Daniel, for sharing a little bit of an introduction about the Aleo protocol. Very quickly, does anyone from the audience have a question they want to ask? You can just raise your hand. Privacy is always, oh, you have one question over here. Let me pass you a microphone. Just give me a second. We don't have much time, so I'll probably just take one quick question. All right. Okay, so introduce quickly your name and just a short question to Daniel. Thank you.
Hi, Daniel. My name is Alvin. Our team is currently joining the hackathon, and we are building on Aleo. One of the challenges we face right now is that due to the nature of the architecture of the entire ZK circuit, programs, right, cannot share state between each other. So will this, let's say if we created something, let's say an ERC20 token in a program, it cannot be, the record probably cannot be consumed by another program to do other stuff. So will there be a workaround for this, or will there be any further developments that you can share with us on Aleo?
I think maybe so. There's like a project internally that Aleo has been creating called ZPass that sort of allows you to be this sort of middleman or middle layer that both humans or even businesses and then projects want to have, and how they want to interface with sort of some of the state. We also have quite a few validators that are familiar with sort of building this infrastructure and architecture on other chains, and some similar other ZK projects that have been building like scanners or indexers. And I think there could be a way. I think something that would be interesting is maybe also take a look into like past projects that I think are interesting to like share data between each other, or like sort of delegate that. I don't know how familiar you guys are with, remember like NewCipher, but like, right, there's like this concept called proxy re-encryption that allows you like sort of pass keys and delegate that if people want to use it, right? NewCipher, Mitch, he was the guy who created Curve, but after he left. But I think that's a pretty cool sort of concept. I think once you get familiar sort of like with the system, which is quite unique or a bit special in how you might be familiar with programming on these other these ecosystems is good. Maybe with specific regards to like data availability, that is what people are familiar with this sort of interaction with L2s, is that you can just encrypt the data on the chain, and you can have provers interact with it afterwards. But
Thank you, Daniel. Sorry. Thank you very much. Let's give him another big round of applause. Thank you very much, Daniel, from the Aleo protocol. You can leave it on the table. Thank you so much.